Sí. 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 How do we find the shortest distance? Sorry. How do we find the shortest distance between the board and the boy? This is boy. Okay. How do we find the shortest distance? What is the? Do we have the formula? Or have you learned about it? The shortest distance. Shortest distance is basically the perpendicular. I mean that's what I know. Right. What do you know about the shortest distance? I know that the shortest distance is the perpendicular line from that one point to another point. That gives the shortest distance. And example number 14, if you see your example number 14 of this slide, find the number C. Find the shortest distance between the two boards and the value of P at which they circle. So if you have that book in example 14, if you see what they have done, let me show you this one. You really get the idea. It's exercise example 14. Example 14, the part C. The distance between two board AB is given to us, like the one that we just figured out in part B, RA and RB, and we get the difference. I mean, distance is between the difference of B minus A, like that, B minus A. So we got that. 3 plus 2t minus 2 minus 2.4t. So that's the result of x component. For the y component, minus 2 plus t minus 5 minus plus 3.2t. So this is the result for y component, minus 7 plus 4.2t, right? And if you see, writing the two displacement vector as a single vector makes the subtraction easier. This variation of mod of AB, that is b minus a, we met in section 3.2, and the minimum functions can be found using the. Okay. So what do you have to do? You have to draw this function, isn't it? You have to draw this function in your GDC and check out the minimum. I mean, minimum can give you, right? GDC give you the minimum, right? So in a very similar way here also, like we don't have the two different locations to then make it one. We have just like this one. So it will be 20
Hello.
minus 3t.
खाना बना रहा है
30 minus 5t, isn't it? So we're going to figure out the distance between the shortest distance between these two. So what I'm going to do, my function will be 20 minus 3t squared plus 30 minus 5t squared. Draw this graph on your GDC and ask the GDC to give the minimum point. That t is the x and y will be the basically the distance. So we are looking for the time, right? Find distance. So
गैस
the y
में
value.
मतलब
I hope you get this. T will be the x. So this also menu function graph anything before, just delete that. Root under 20 minus 3x squared plus 30 minus 5x whole square minimum. Yeah, it is 1.714. So the true significant figure will be 1.71, and and x value is 6.176, so 6.18. So time at which the minimum distance occurred, it will be 6.18, and the minimum distance is 1.71. Right? Get this? Yeah. That's fine. Okay. Yeah, they're dealing in meters there. They're dealing in meters. Okay. All right. A particle has a position vector 3I plus j when t is equal to 0 and is moving with the velocity of 10 meter per second in the direction of 3I minus 4z. Find the position vector at time t. So we need to create the position vector at time t, isn't it?
Hello. कोई बात नहीं.
So how do we create the distance? As we have seen earlier also, the direction vector. This is direction vector, right? And moving with this speed. So for the direction vector, we always do 10 times 1 upon mod of 3I minus 4j and mod close. Then we have the direction vector of 3 and minus 4. So it will be 10 times. Yeah, I'll add it if you just thinking like why I haven't do this 3 and 1. I'll add it after that. And this is all happening here with the direction.
Ranchi mein.
Right. I'm doing this for the direction, right? So okay, so I'm fixing it all along. 3 1 plus, and if you figure out the magnitude of 3 and 4, 3 square and 4 square. 3 square is 9, 4 square is 16. So root 125. Root 125 is 5. So it's 10 over 5 and 3 minus 4. So it will be 3 1 plus.
जिसका बिजनेस है तो वो तो जाते ही है ना.
3 minus 4. But we should also mention t over here, so it's minus t over here. It's time t, so t times t. Or you can say 3 1 plus t, 2 times 3 6, 2 times minus 4 minus 8. Or you can write this as 3I j, the position at t is equal to 0, and other positions of t would be t 6I minus 8j. Okay. Part B. Its position vector when t is equal to 4. Now, it's simple because we already have the general position vector determined. This is basically the general position vector at any time. So when t is equal to 4, what I'm going to do? I'll substitute t here to get the position. What do you say? I'll substitute t over there to get the position. So 3I plus j plus 4, 6I minus 8j. So 3I plus j, 6 4 24, 8 4 32. 24 plus 3, 27I. J minus 32 is minus 31. This will be the position at t is equal to 4. Clear? Just tell me if you have any doubt over here.
हाँ हो जाता है कभी कभी खराब। बारिश भी तो यहाँ हो रहा है।
Yeah. So yeah, this is the position of the particle at t is equal to 0, right? And we created the direction at, I mean, just making it very initial one, right? So to get the initial one, I need to divide the given direction in the direction of 10 km per hour with its magnitude. That's how we make the unit vector, isn't it? If, for example, because this information in the direction of 10 km per hour in the direction of 3i 4j is something like that. We know the price of 10 mangoes, right? But I need to fix that what is the price of one mango, so that next time when someone asks me what is the price of 5 mango or 25 mango or 100 mango, I'll answer it accordingly. Are you getting me? So this information is like that. It's kind of price of 10 mangoes. And from the price of 10 mangoes, how do I answer the price of 100 mangoes or 25 mangoes? I need to know the price of one mango, isn't it? Right. So that's what we are doing it here right now. We're converting the direction in the unit, which means divide the component of given direction vector with their magnitude and multiply with the 10, because that's